Okay, gold already took the test, the chapter 18 test. Green is taking it Monday. Both groups, after your test, we're going to do a quiz over naming and writing chemical formulas of ionic compounds. Same stuff that was on the test. So I want to make sure you've got it down. After we're all done with that, which for one or both groups, maybe after the break, we'll talk about naming and writing chemical formulas for molecular compounds, which is a different system. So we have two systems in ionic, two in molecular, and only one of those we'll look at. The two in ionic was binary and ones with polyatomic ions. So this would be a good test review. If you're doing this before the test, you can test review. That quiz has some for credit, some for bonus. So you need to get some right to get a decent grade. And if you do really good, there's some bonus. But also that quiz, I want to see how prepared you are for chemistry. First day of chemistry next year, you'll get this quiz and another one back to show how prepared you were. You can take chemistry if you flunk them, but it's a good idea to do very well and already be prepared. So you'll be well informed as to what you did. Okay, so here are some mixed practice. These I already did in the video. It's already in the flip charts. It's already in the weekly notes, or will be here soon. So I've done this. I'm going to do it again separately here so you can do this. So there are, what, 1, 2, 3, 4, 8 of these in mixed practice. There's two different kinds of naming systems. How do you know what to do? Well, if you pick out the ones that are ides, they're binaries. Sulfide, nitride, oxide, except for this one. I'm not going to give you a hydroxide on the quiz unless I screw up. This is actually polyatomic, but the ides are binaries. So it means you name the first one and you name the second one. So you got to know what column they're in on the test. On this quiz, I'll give you a paper that has, it's a black and white version of this. Whoops. This. So calcium is in this column. Sulfur is in this column. Taken to, giving to. That's a match. You want to make matches. So, since calcium gives to, sulfur takes to, and you have a match, it's just CAS. Then sodium nitride. Sodium's here, given 1. Nitrogen's over here, taking 3. That's not a match. How do you make these match? You have to get more sodium. So it, whoops. It has to be Na3N. Gallium oxide. Okay, gallium is under boron a couple positions, giving 3. Oxygen's over here, taking 2. Not a match. How do you make it a match? I need a couple of 3s to move 6, and 3 2s to take 6. So that one should be Ga2O3. Okay, calcium hydroxide, this is the one ide that it is polyatomic. The hydroxide ion is OH minus, and it's with calcium. Calcium is 2 positive, OH minus. There's one that doesn't match. We have to have another hydroxide. So it's CaOH, and I have to have 2 of them. So I'll try not to give hydroxide to you because it's an ide. Okay, let's do the other ones that are polyatomics. Magnesium acetate, aluminum chlorate, carbonate, iron sulfate. Now, you have to have, and you will have, the table for this, which is here. Okay, so I know that I had, this is on page 450, for page 569, table 4. Sulfate is 2 minus, acetate is 1 minus. I don't remember what all else was in there, but you need this table. Okay, so magnesium acetate, is C2H3O2 minus, chlorate is ClO3 minus, carbonate is CO3 2 minus, and sulfate is SO4 2 minus. Okay, those are just off that table. Now, you cannot put charges in your answer. If you do, it's wrong. Okay, magnesium acetate. Magnesium is in the give to column. Acetate took 1. This is not a match. How do you make it match? Have 2 acetates. So, I parentheses that and make that a 2 and put it with my magnesium, and that's what magnesium acetate is written like. Next one. Chlorate. Aluminum chlorate. Aluminum is over in under boron. It gives 3. Chlorate valence electrons. Chlorate took 1 valence electron. This is not a match. How do you make these match? Well, you have to have 3 chlorates. I already got 3. No, you have 3 oxygen. You have to have 3 chlorates, the whole thing, with an aluminum on the front. Okay, then ammonium carbonate. All right, if you go back to that table that I got those off of, ammonium is the one polyatomic ion that you're looking at that's positive. And ammonium is positive 1. So ammonium gives 1, carbonate took 2. This is not a match. Ammonium gives 1 valence electron, carbonate took 2 valence electrons. How do you make it a match? You have to have another ammonium. Get rid of that charge. So I have to have an ammonium, NH4, and I have to have another ammonium, NH42CO3. You don't put charges in your answer. Okay, and then boron sulfate. Sulfate off that table took 2. Boron is in the give 3 valence electrons column. Boron gives 3 valence electrons. Sulfate took 2 valence electrons. This is not a match. I have to move 6. Switch the numbers. I have to have 2 borons and 3 sulfates. So 2 boron, B2, SO4, 3. The whole sulfate ion is 3. And you don't put parentheses around your boron because it's one element. Now let's try some more mixed practice. This is probably a little bit of naming. Okay, here I've got them sorted out into binary and polyatomic. Okay, so my binaries are going to be ides. So the naming, this is calcium, chloride, this is aluminum, 2 names, bromide, Strontium fluoride is going to be SR for strontium and F, but we got to check for numbers. And lithium oxide is going to be Li and O, but we got to check for numbers. Okay, for the strontium. Strontium is in the periodic table under calcium. So it's right here, gives 2 valence electrons away. Fluorine, over there on the right, takes 1 valence electron. This doesn't match, so I need another fluorine. Okay, lithium oxide. So that was my fluorine. Here's my oxygen. Takes 2 valence electrons, lithium's over here. Gives 1 valence electron. This does not match. Lithium gives 1 valence electron, oxygen takes 2. How do you make it match? Get another lithium. Should be Li2O. Okay, let's come over here and do the polyatomic ions. Now, I'm not going to pull up this table every time. You can screenshot it or open your book. You've got a copy of the book. You can toggle back and forth when you open that window. So, here's your polyatomic ions. Ammonium's +1, -1 charge for acetate, chlorate, hydroxide, and nitrate, -2 for carbonate and sulfate, -3 for phosphate. So I'm not going to toggle back and forth. That's where that is, though. You have a copy of your book at home. I mean, you can open that up and look at it. It's page 569. Okay, so ammonium. Oh, this is naming. This is ammonium, phosphate. Okay, the rest of this is acetate. So it's potassium, acetate. No, you don't just list the elements in there. There's always somebody who tries to don't waste your ink. That's not how it's done. Now we know ammonium is NH4 plus. Gives 1. I'm going to write that down because that doesn't end up in the formula. Chlorate is ClO3 minus. Since ammonium gives 1 valence electron away and chlorate takes 1 valence electron, that's a match, so it's just NH4ClO3. Boron carbonate. Boron's B from the periodic table. Carbonate from the polyatomic ions is CO3 2 minus. Carbonate takes 2 valence electrons. Boron donates 3 valence electrons. This is not a match. How do you make it a match? We can just switch the numbers, but you got to move 6 electrons. You got to have 2 borons and 3 carbonates. So there's 2 boron, carbonate, you want 3 of everything. So it's B2, parenthesis, CO3, 3. Ammonium phosphate. I already did it up here. Already did it. So it's NH4,3PO4. Phosphate ion takes 3 valence electrons. Ammonium ion gives 1. It's not a match. You have to have 3 ammoniums. And then sodium nitrate. The nitrate ion is NO3 from the polyatomic ions table minus. Sodium ion is over here on the left. And a positive gives 1. This is a match. It's just NaNO3. Okay, there's your practice. If you can do that pretty reliably, you're very ready.